What's up guys, Daniel here. Welcome back to the Crosslink channel. This is a combination of a Q&A with a build of the Ender 3 Pro. I know this is not the newest printer, but I'm building this printer just because I need a printer for experimentation with mainboards. This printer has an 8-bit mainboard and I'm immediately going to replace it with the SKR 1.2 and the TFT35. I got an upcoming TFT43, 50 and 70 review that I want to do, and I need a printer with an SKR mainboard for that. I also want to test out the new 427 Creality mainboard, which is also a 32-bit mainboard. So I kind of need a printer to do this because all the other printers that I have are currently I don't want to touch them because they are being used for printing and I don't want to break them. And I'm also changing a little bit the way how I'm doing reviews. So first part of a review is always going to be kind of a more or less raw and a little bit cut version of this unboxing and starting process to get the printer going. That's for people who want to watch this and want to join me on this. This is by far not a detailed and also not concise guide. This is more like the experience of building it. And then I'm going to put every printer, except this one, because this is just the experimentation printer. Then every printer that I'm unboxing in this kind of video way, how we do it today, is going to go into this time-lapse setup for about 2 weeks. And in these 2 weeks, it's gonna print around about 200 to 300 hours non-stop. First of all, this is good because I can create new time lapses, which I'm kind of excited at the moment. I like those time lapses very much. So you can see all kinds of issues that happened during these 2 weeks because like 300 hours of printing is really serious. And so it's gonna reveal a lot of the issues that a printer usually brings when it's unmodified and out of the box, basically. And then after these 2 weeks, after collecting all that data and looking at the results, I'll do a pretty concise, hopefully very much under 10 minutes review where I'm just going to present you like the facts, the details, the issues, also the fixes that I had to do in this hopefully under 10 minutes video, and then basically giving you advice. Is this a good printer? Would I buy this printer? And that's it gonna be. So without further ado, let's start with this build. I also don't want to forget to mention that at the end of this video, I have a giveaway waiting for you. A little one, but probably exciting enough. And let's just go. And then I think after we would start with the first unboxing, then we do kick off the Q&A, which has been going for about, I think, 2 to 3 weeks. I've been asking you on YouTube, what are you the most daunting questions that you would like to ask me? And then also asked you on Patreon the same. And I will start with the Patreon questions first, and then I'm going through the YouTube questions. I'm going to interrupt this build from time to time, so to say, to answer a question, and then we continue the build. And I hope this is kind of an interesting way to do such a video. So let's start to unbox this guy. And I also have different views here, so we can switch to the overhead so you can see what's inside of such a printer box. So here we have some very short introduction and assembly manual. Probably have a look at this. So for the start, I'm thinking about, I will probably not assemble the whole thing before I switch out the mainboard. From what I normally know about this printer is that the mainboard compartment is underneath the printer, so it's probably easier to just go right away and exchange the mainboard. So let's take out this first thing here. This is where the mainboard sits, and there's a few screws here, and there's also some on the side, I guess, if I remember correctly. Yeah. So before I open this electronics box, let's go and answer the first question from Patreon. Which printer could you recommend to choose for buying Ender 3 V2 or CR6 SE? I think a comparative would be appreciated. Well, that's actually not such an easy question to answer. I would say I've looked at all these printers like Ender 3, Ender 3 Pro, Ender 3 V2 and CR6 SE. And if you look at the features that all these printers have, and if you have been looking around for the reviews of those printers, you can pretty much say that most of these printers are pretty good. I mean, almost every printer is good today. There's not really bad printers anymore, but I've seen that, for example, the CR6 SE has some quality issues with the main board. So Creality is reaching out to those people who have seen the smoking main boards, as they call it, and probably sending out some replacement. About the Ender 3 V2, I'm pretty positive about that. I think it's actually going to be the real successor of the Ender 3 because it has some exciting new features. The price point, I think, is pretty much perfect because it's like just about a little bit over €200 or $200, depending where you buy it. But it's not like as pricey as the CR6 SE. And if you think about the pricing of the CR6 SE, how much better is it really? Like, how many more features are you getting if you have the Ender 3 V2, but you have to pay around €100 or $100 more for the CR6 SE? What are you getting for this €100? A handle to carry it, and maybe this like sensor or this new sensor for homing, which is using the nozzle as the sensor. I think it has been shown that this can be also built in another way, and also the BL Touch is a perfect sensor for me, so I don't really need anything new and fancy. So I'd say the Ender 3 V2 is perfect enough, it's good enough. If I would have like the Ender 3 and I would be thinking about an upgrade because I want a better printer or a newer mainboard, probably would go and upgrade the Ender 3, because the Ender 3, this Ender 3 that you've seen in the time-lapse video that I've just released on my channel, it's been going for probably about 2,000 hours of print time. And I had literally almost zero issues. I have replaced the nozzle twice now. I've replaced the PTFE tube once. I've did some upgrades, especially the fans and the blowers for the filament I have improved. But this wasn't expensive. Like, this was around probably €100 maximum of upgrades, and it was pretty exciting. It's probably on par with like the CR6 SE even. Like, from the output, the quality it can create in terms of print results. Long story short, I would go for the Ender 3 V2 and maybe do some little upgrades to make it really perfect. I think it's the better bang for the buck. Let's continue to open up this box. Here's another one that needs to be removed. So that's good. That's one recommendation I will give you. If you replace the mainboards on this printer, on the Creality printers, not all the cables are marked or labeled. So I will go and take a little bit of a labeling tool here and create little labels for the cables that don't have any labels, so I don't forget what these cables are for. So the motor cables are all pretty much labeled with a little yellow flag here stating which motor it is, so that's not an issue. So last thing to disconnect here is the mainboard power. It's coming from the power supply. These two cables here, and then we're done. So we should be able to remove it fine. The next thing to do is to get the SKR 1.2 mainboard and put it in place. But before we do that, we'll go and answer another question from the Patreon Q&A. So this is the new question from Rajan. Can the Creality 115 and or SKR Mini E3 be configured for a Delta printer, and how? And I would say yes, of course it can be configured. The question is not if it's technically feasible, but it's probably more a software configuration thing. So what is a Delta printer using? A Delta printer usually has 3 motors for moving the print head. There's 3 main lead screws that drive the print head up and down, and these 3 motors are run independently. That causes the print head to move to the side or up and down. And so we have 3 motor outlets for that, so that's not an issue. So we have X, Y, Z, which will be motor 1, 2, and 3 for the Delta printer, and then we have the extruder motor driver, which is the 4th one, and that's actually all you need for a Delta printer. The question is probably more, what is the configuration that you need to do in Marlin firmware? So what we can do is, we can have a look in Marlin firmware, and there is, in these example folders, there is one folder that's called Delta. And what you can do is, you can make the assumption that if you have an Ender3 mainboard or an SKR 1.2 or any other SKR mainboard, you can try out and see, okay, what kind of Delta printer is my Delta printer? Is this Delta printer here in this list? And then use that as the starting point. Yeah. The problem with these configuration files is going to be that these are also configured for the specific mainboard in that specific Delta printer. You need to change in the Marlin configuration in the line where it says what mainboard are you using, the mainboard line, so we can look at that. What is this? So for example, we can have a look at the Anycubic Cossel, whatever that printer exactly is. I don't actually know that printer. And then we'll look for the motherboard. So this is like currently configured to be a board Trigorilla 1.4. So if you want to go for an SKR Mini E3 V1.2, you will use this string and put it into the mainboard line and replace whatever there is in that mainboard line. And that's the starting point. I'm not saying that this is all you have to do, but it's a starting point. So you can use an existing Delta configuration. Things that might not working is probably the end stops, though they might be inverted. You might also need to invert motor directions. That's also possible. So that's the experiment that you're doing, obviously. But I mean, that's why we're here, right? Let's go back to the build. I'm picking the SKR 1.2, putting it right in here. If you look at the original mainboard, this is the SKR 1.2. So they look pretty much identical from the layout, and that is intended, of course, because this SKR 1.2 perfectly fits in the same spot. So you can see the mainboard fits in here pretty well. Okay, so next step is to connect all the cables back to the mainboard. I've hopefully marked them all correctly, so I can just do it very easily. Problem here is that power that's coming from the power supply, this cable is quite short. There is not very much play here, but it should still work. So we have to do that first. And that's basically it. All the cables are connected. And I think it's time for another Q&A question from Patreon. Nicholas, he has seen many videos explaining how to upgrade to a 2 lead screw setup. And to keep it short, his question is, what is the advantage of having 1 lead screw on the Z-axis versus having 2 lead screws on the Z-axis? Well, for the Ender 3, I discovered that sometimes, especially if you're printing taller parts, the problem is sometimes that the weight of the extruder that's moving along the x-axis can cause this horizontal bar to a little bit tilt. That depends how well everything is tightened, like how well the rollers, the wheels against the frame are tightened. That problem adds up. The higher you print, the worse the problem gets. And that is the reason why having 2 lead screws basically supporting the horizontal bar where the extruder motor runs along, then your whole prints are going to be, I'd say, more accurate, especially if you are printing higher things. So if I imagine that I would go and replace the standard extruder on this Ender 3 with a Hemura system, as I did it on the AM8, for example, I would probably go for a second lead screw on the Z-axis, because that would make sure that the added weight doesn't cause any kind of printing issues. So on the second part of the question is, why does the Prusa Mini have just 1 lead screw and is still precise and stable? It is just a smaller printer. It's very small compared to this one. It's quite a bit smaller. So there is less weight on that arm that's going to pull it down once it goes to its very extent. Like the Ender 3 is probably borderline. It's probably not big enough to cause really severe problems. Almost any bigger printer has 2 lead screws for the Z-axis because of the additional weight and because of like the frame being so large. So I hope that answers your question, and let's get back into the build. So we have installed all the cables, and the last thing to do here is to install the electronics case fan. So I'm going to plug in that cable here. It's the only one left. And there's one thing missing. One thing is missing. That is the display connection. I think it's the TFT connector. Here on the main board, there's a TFT connector. We need that TFT cable. That's in the package of the TFT35. So when we connect this cable has two little connectors. This the larger one with the 4 pins and a small one which is the reset pin. And the reset pin goes to the left. If you look down on the main board, left side is here, closer to the blue and yellow cable here. So it's in place before you close this compartment. So electronic installation is pretty much complete in terms of the main board. It's not sponsored. Okay, let's go and answer another question from the Patreon page. It's a second question from Nicholas, and he is asking whether to install a direct drive system and what are the advantages of a direct drive versus a Bowden setup. So this is an interesting question because there's a lot of answers out there. So I'm not claiming that I have the answer to this question, but I have an idea why I want a certain system on a specific printer. For me, the Ender 3 with the Bowden setup is pretty much perfect. I mean, the results, you saw it also in the time-lapse videos, pretty nice results. I would say pretty solid. The only issue that the Bowden system always will have is with flexible filament. This is not going to be easy. If you want to print flexible filament, you can do it with the Ender 3. I did a extruder modification. Originally was created by Chuck from the Chap channel. It's actually guiding the filament, the flexible filament, much closer to the gears, so it can't escape that path. With that modification, you can print almost any flex filament, maybe not super flex from Ninja Flex, but more or less you can do it. If you print very slow. And that is, I mean, that is one of the points where like the direct drive is shining. You can print flexible filament very fast compared to a Bowden setup. So the second part of the question is, does the direct drive introduce necessarily some ringing into the prints? And the answer is maybe. It could be, because the print head obviously is going to become much heavier. And on the ANIT A8 that is the case. And when I switched to the AM8 frame, that ringing issue actually disappeared for most part, I would say. And the reason for that is, if the frame is very stiff, then you will have less ringing. Why is that? Because ringing is introduced by movements in the frame. So if the vibrations can build up in the frame and they cannot escape or they're not let out of the frame, then this will show up in the prints. And if the frame is very stiff, then those vibrations have no other way than to go to the base of the frame and then to the table, and there they need to be absorbed. The other problem with Bowden that I sometimes see, and that's the reason why I swapped out my PTFE tube on the Ender 3 recently, is that the gears at the extruder motor, they are going to grub into the filament, and this filament will rub inside of the PTFE tube. The filament rubbing at the inside of the PTFE tube is going to wear out that PTFE tube over time. And that can cause additional and increasing friction over time. And you don't really know when this is going to happen, but when you see under extrusion happening and you are pretty sure that it has nothing to do with the gears on your extruder, then it's probably the PTFE tube. And then if you have a printer which has a really large build volume, the PTFE tube is also going to be super long, then the problem will be even worse. So let's get back to the build. What's missing here is the frame. So we need the vertical extrusions. We'll do this for both vertical extrusions. And we could also answer another question in the meanwhile, I would say. And this is going to be the first question from YouTube Paul. So the question is, I have an ANIT A8. I took it apart to build a new printer. Out of it, added an MPS Gen 1 and Gen L, I guess, TMC 229, touchscreen, Beal Touch and linear rails. I would like to make a DIY printer, something like Core XY, but X and Y independent of one another. What do you think, or do you have suggestions? If I remember correctly, the Ender 5 is kind of what you're looking for in terms of how to build that, because Core XY, from my point of view, is to build it from scratch. If you have no previous experience, is probably quite a challenge. I think it's super interesting. I was also tempted to do it at some point. It never grabbed my attention so much that I was feeling, okay, I have to do this. This is super crazy. Let's do it. So if you want to go for it, I would have a look at how the Ender 5 is designed, because that kind of design, it looks like a Core XY if you look at it like just on a glimpse, but it is not exactly a Core XY. It has what you want. It has independent X and Y. If you use that kind of idea, that is much, much simpler, and it still will probably work and give some really good results. Okay. This looks fine. Still not sponsored. The power supply on the Ender 3 Pro is also a different one. They claim it's a Meanwell power supply, an upgraded power supply, which is very much appreciated. I'm not sure, however, if it's more silent, so we'll see. Good, so the power supply seems to be fixed, and that power cable underneath the heat bed is here. And these two cables are now getting plugged together. Let's pick the next question. From Wim. Do the stepper drivers on a Big Tree Tag SKR 1.4 have to be provided with cooling, and how do I make this? It's always good to have cooling for your stepper drivers. The first thing you want to have, of course, is those heat sinks on your stepper drivers. So these are provided with the main board, but if you have a SKR 1.4, or if you checked out my other video where I have built the SKR 1.3 with 2209 stepper drivers, they have heat sinks which I had to glue onto the stepper drivers. Then I added a 120mm fan on top of the whole main board. Let's continue with the build. Step 2 is also about the display. Here is the display. It's already mounted to that display holder. I'm going to remove this electronics board from the holder part because I want to exchange it with the Big Tree Tag touchscreen display. So there you go. So this is the Big Tree Tag TFT35 E3 version 3.0, and this fits in the very same spot. Little tip here, if you actually want to hear the speaker, remove this little sticker here, because that covers the speaker and otherwise it will be very silent. We want to mount the display to the frame. Talking about the mainboard connection with the display, in the beginning I made a mistake. I took these two display cables and I actually routed them out here where every other cable comes out, but actually they have to come out here on the side of the electronics case, so they can go to the front. So I fixed that quickly, and now we are ready to connect the display. For the TFT35, the colored one goes to the EXP3 connector, which is this one here. And then the serial RS232 is this one here. And that's it. Next step, the end stop switch. Mount it here on the side. So here on the side, and then fix it. And then finally connect this little cable to that switch. I will say we'll answer another question from YouTube. Okay, the question is, one of the big pros about the Creality 8-bit 115 boards was the silent drivers. Are the new 32-bit boards also using silent drivers? How about your SKR board? So first answer here is the new 32-bit mainboards from Creality. When you buy a new printer, you can, in the Ender 3, in the normal Ender 3, you can get either a better version of the mainboard, which has silent drivers, and a cheaper version of the mainboard, which has non-silent drivers. Teaching Tech, Michael, he did on his channel, he did a explanation about this already. And what I can recommend is really checking before you buy what kind of mainboard you will get. So it can be that it has non-silent drivers, and if you invest a little bit more, you can get the silent drivers. If you buy the mainboard separately, as I did, you will get the 427 mainboard from Creality currently, and that has silent drivers for sure. And the SKR Mini E3 1.2 and 2.0, they also have silent drivers. The next step in the manual, the vertical lead screw and the motor. That motor goes here on the side to the back of this extrusion. Let's answer another question from YouTube, from Mike, and he's asking, how much and what printers do you own? Well, I own an Ender 3, which I heavily modified, and you've seen those videos on my channel. I've also had an ANIT A8, that is now an AM8, so that has a long history. I have a second ANIT A8, which is still on the acrylic frame, and I'm still planning to modify it into the Tatara frame. The Tatara frame is a full steel frame. That's these three printers. Then I have now this Ender 3 Pro, which I'm currently building as a testing printer for new mainboards, the new Creality mainboards and all the BTT mainboards. I have an Ender 3 V2 and a CR6 SE. I'm gonna do extensive build videos about these two printers in a while. So that's basically all the Creality printers. I had a CR10S Pro, which I sold. I also had an ANIT A8 Plus, which I sold recently. I'm currently testing the Elegoo Mars Pro. So this is my first SLA printer. So I'm just getting into that. It's pretty nasty. So yeah, and I have the Adventurer 3 still that I also tested on the channel. I have the SC10 Shark, which is some printer that was sent to me for testing. I didn't unbox it yet, so I will do a video about it very soon. And I have a little nano printer, I think it's called. It's a very, very small printer that I want to test out just for children and educational reasons. And yeah, that's it, I guess. I'm not sure yet which ones I'm going to keep, because I need the space. I don't have that much space here, so probably not every printer can stay. So let's see. That's the printers that I have. So the next thing is that this extruder frame is going over the extrusion. So there's this eccentric nut, and you just want to make sure that it doesn't wobble around. So it's just tight enough that it doesn't wobble and not too tight, so it's much harder to move it. So just find the sweet spot. This is temporarily fixed, but it will be tightened when the belt goes in. And this is actually step 8. So we need the belt now. We insert it here, fix it first on one side, wrap it around, and then it's going around the motor. Okay, so the last thing here to do is to insert this belt into this little slot here. This is now a complete loop, so it's fixed in these two slots. Okay, so it's going to be aligned and sliding over the extrusion. So, and now this whole frame should come down pretty smooth. And last step is to close the frame, but let's go and answer another question. The question is from Charles. What do you consider to be most important area of an FDM printer to keep on top of in terms of maintenance to ensure consistent prints? Yeah, I mean, there's a few things to consider. The PTFE tube will wear out over time, so I would exchange that maybe once a year. I would also exchange the nozzle once a year, because it's also gonna somehow wear out. Either it might be scratching on some of the surfaces, or the inside of that nozzle might wear out a little bit depending on the material and the temperatures they're using. Also make sure that no dust and no particles, especially leftover filaments, get in any of the electronics fans or the cooling fans, so they are not blocked by filament. Use a vacuum cleaner to clean the printer once in a while. And also make sure that the motors, especially the fans, are always working. These fans tend to stop working quite quickly sometimes, so you want to make sure that these fans are always working correctly, so everything gets cooled. And if they start vibrating, making strange noises, it's probably time to swap them out. And I think I did that also one time per year, I would say, because I'm printing a lot. So yeah, then the next is like checking these wheels here, these rubber wheels. They tend to wear out over time. Actually, that starts pretty early, especially on the heat bed, and they are underneath the heat bed, so sometimes you just don't see it happening. But if you're wondering why there is a lot of rubber on that extrusion, that might be because of the wheels being too tight. And if you see that happening over time, that's totally normal, of course. On a long period, they're gonna wear out, they're gonna change shape a little bit, and they might parts might start to shake and wobble around. Then it's time to swap out those wheels. That are the things I do frequently. Good judgment, look at everything, look at the cables. If outside of cables look strange, if you have to swap out cables. But in general, these are the considerations I would make on a normal, let's say, weekly, monthly, yearly basis. We will close the frame, and this is how it will work. Okay, so this is the X motor, and there's a cable marked with X. So we're gonna connect this here. And there's an E cable, extruder motor cable, and that goes in here. Okay, so the frame mount is complete, I would say. Everything looks connected and all the cables are plugged in. One last thing to do is to mount the filament holder, and why don't we do that while answering another question? And the question is from Low-Tech Greg, and he says he loves the vid on just going to 32-bit. So thanks for that. He's asking, can I address the quality issues that have been mentioned in several forums and posts and boards for BTT mainboards? And he's also looking forward to my review of the implementation of the SKR Mini V2. So my honest answer is I've never had any issues with the Big Tree Tech boards so far. So I can't even speak of this mainboard, which is in this printer right now, the 1.2 Mini. So we're gonna see if that works as expected. Same goes for the version 2, which I'm also going to install on this printer, because this is going to be my experimentation device for new mainboards and new displays. So far I didn't have any issues, but the best recommendation I can give you if you have an issue with your mainboard is really go and contact the vendor and the seller. Sending something back to China is always difficult, and you have to find a seller on, for example, AliExpress, where you see a lot of positive comments. Maybe people also complain about the support. So be aware that ordering stuff from China is always a risk. And if you buy it on Amazon and you buy it from a vendor that's not shipping from China, it should be easier to send it back to Amazon and get a replacement. I mean, same goes for the printers themselves, that it is absolutely possible that you order an Ender 3 or any other printer and it's broken when you get it. That is the risk that you're taking, and this is just the honest answer. let's just plug this printer in and just see if at least the screen is turning on. There is probably a super old firmware on this mainboard and also an old firmware on this display, so we're gonna upgrade both. Here we go. And actually there's Marlin bugfix 2.0 installed, which is funny that they didn't use a release version. And yeah, let's try out homing maybe. Just quickly see if anything is moving. And it seems to work. And stop switches seem to work. Z homing. Zap homing didn't work. Why is it not homing in the Z axis? I am pretty sure that I plugged in the Z motor. No, I didn't. I forgot to plug in the Z motors, guys. There we go. Always good to double check your cables, so I forgot to plug in the Z motor. And now it's also homing the Z axis. Yeah, that seems to work. Moment of truth. So let's do some preheat for PLA. So we can see that the bed temperature is raising and also the nozzle temperature is raising. I also want to test if the Marlin mode and the touch mode are working correctly. So I'm switching over to the touch mode here. And I can also see that it's connected because there's no error and I have a temperature readout. So both things seem to be working. So we can also trigger a movement and home from the menu. And that also seems to work. So the display is connected correctly. Everything seems to be working. And what I want to do now is really flash the latest Marlin firmware to this printer. So I'm going to download that quickly and I also show you what configuration to pick just as a default setting to get it going quickly. We can go to the releases here and the latest version is 2.07. So let's open that. Let's unpack this folder. The second step is really to go into that README file and download the latest configurations, which is also a zip file. And then go into the configuration release 207 subfolder and pick from the examples directory the Creality Ender 3 Pro directory. And here you see we have defaults for all kinds of BigTreeTech mainboards, luckily, so I'm going to use the BigTreeTech SKR Mini E2 E3 1.2. Copy all these files and then overwrite the original ones, which are in the Marlin folder of the Marlin firmware source codes. Replace everything and then we can go to the Marlin 207 main directory, open Visual Studio Code, and then we should be ready. So don't get me wrong, I'm going pretty quickly on this step because I've shown how to do it for several other printers and also for the Ender 3 several times on this channel. Nothing has changed so far. The whole process is identical. So I'm just going to briefly show you how I'm compiling this and I'm flashing it to the mainboard. And that's really pretty straightforward. So I'm not changing anything anymore here because we're using the default configuration files. I'm going to use AutoMill Marlin and just hit the compile button here. In the next step, I have to choose an environment to compile for. And to be honest, I didn't know about the 512K option. I digged it out from Reddit and it says that the chip on the Mini E2 version 1.2 actually has 512K of program memory, but by default you can only use 256K. This is a way to work around that limitation and use the full 512K. And I never tested that before, so I'm gonna go for the original one. And if your firmware is under the 256K limit, then you're anyways fine. And if not, we can always try the 512K option to see if that is working. Okay, so the firmware build was successful. So I'm opening up that folder. It's in the Marlin 207 main directory. There's a .pio subfolder and a build folder. And here we go with the STM32 folder. Here we have the firmware bin. That's the file that we want to copy over to the SD card. So I'm copying that, copy, and the target is our USB drive, and we're gonna paste it here. Also, this is the old firmware that's currently installed. It's always going to be renamed to firmware.cur, so I'm going to keep it, just renaming it to _old. As soon as this new bin file is flashed to the mainboard, it's going to be renamed to .cur. So let's insert that SD card to the printer now. And now you just turn on the power, the firmware gets automatically flashed, and as soon as it's ready, so we can switch back to the Marlin mode, it should show us the printer menu. And here we go, Marlin 207 is flashed to the mainboard. Very good. Last step to do is to flash the display with the latest BigTreeTech software. Same procedure here. We use the same SD card. This is a full-size SD slot, so we need an adapter. So you can see firmware has been flashed. This is also an indication that it worked because it has been renamed to .cur. And last thing, we need the firmware for the BigTreeTech, github/BigTreeTech. And I think there is a touchscreen firmware repository here. Yeah, so I'm going to download that as a zip file. Let's unzip that. Yeah, that's a new version. So let's see. Unified material theme. The only thing that you have to do to get this working is to pick the right bin file. This should be the right file, the BigTree TFT35 version 30E3, and this one. And then we also choose the TFT35 subfolder that has all the images and assets, that the icons basically. We copy both to the SD card, and then we should be ready to put it into the SD card reader of the display, not the main board. That won't work. Here at the side is the full-size slot, so I'm just inserting that SD card in here, turning on the printer, and here we go. It is updating the firmware. That's gonna take a few seconds because it's also copying fonts and assets like icons and the startup logo. So it says I missed to update the configuration file. That is an easy thing to do. So we just have to go back to the BigTreeTech firmware folder, and there is a config ini file that I forgot to copy. So I'm going to copy that now, copy it to the SD card. So we just have to reinsert this and then reset the printer. And that's going to update the configuration. Touchscreen calibration. So let's do that. And it seems we are successfully updated to the latest version. Ender 3 Pro ready. Really nice. So I would say, let's turn this printer off. Let's pick the last question from Syntax QME 3D. Why do so many people believe the misconception that a Beal Touch is a plug-and-play device and that it will fix all of their leveling issues? That is a very good question, and to be honest, I've printed with my Ender 3 for most time without any leveling probe. I just used 3-point or 9-point bed leveling, which is available in Marlin firmware. So it's called mesh bed leveling. That's simply to enable, and it works pretty fine. But even if you are still on the stock firmware, if you have leveled your bed correctly, you're probably going to get very good results right from the start. So before doing any probe installation, make sure that you have done all the steps necessary to level the bed correctly, and then you most probably don't have the need for any kind of probe. The probe is just something that makes sense for most part if you're swapping out the surfaces a lot. So if you want to print on glass and then next day you want to print on a metal plate surface, and then the next day you want to swap to something else, then this kind of bed leveling probe makes sense because it's going to work with all these different kinds of surfaces. I installed it right now because I wanted to try it and I wanted to show it to you how to do it. But it's also, I mean, if you've seen the video, if you're on the stock mainboard, that is not a super easy installation. It requires some work, some prerequisites, and then it works. but it's not a must-have, I would say. And of course, it's not going to solve all your issues. So let's come to the giveaway. And I'm giving away a free Creality glass plate for the Ender 3 or Ender 3 Pro. Just go to the comment section of this video and put your Instagram alias in a comment in the first 48 hours when this video was released, and then I'm going to pick a winner and send this glass plate to the winner. So good luck. Also, I hope that you like this kind of combination of a build and Q&A. If you did like it, please give it a thumbs up. If you didn't like it, give it a thumbs down. I'm always happy to see your feedback coming in. We're gonna do some more of these printer builds. Then this should be it for today, and we're gonna see each other next time for another video about 3D printing, 3D scanning and other stuff on this channel. Until next week, I hope. Bye bye.